What up, folks? Today we're going to look at solving oblique triangles, which means we want to solve a non-right triangle, find the angles and the sides. So let's take a look at one right now. We want to find the value of z, and how are we going to do that? First off, I think this diagram is supposed to be like a lookout tower, a second lookout tower, and then they're both spotting a fire off in the distance. And we know the angles out to the fire, and we know the distance between the two towers, and we want to be able to use that to figure out how far away the fire is. So notice we've dropped an altitude from the fire down to the 2,000 meter line between the two lookout towers. We have a problem. We want to use some right triangle trig, except we don't know any of the side lengths of the two right triangles. We know that the total distance of the base of those two right triangles is 2,000 meters, but we don't know the individual bases. So what I'm going to do is I'm going to draw this pink triangle here, and I'm going to label it with what I know. I know that's Z, and I don't know what that base is, so I'm just going to call that X, but I do know that that is a 54-degree angle. And then I'm going to draw the blue triangle and label what I know. I know that's 30 degrees. I know that's that same Z. Don't know what it is yet, but I know it stands for Z. I know it's the same side as that pink triangle. And what are we going to call that base? Well, we know the blue plus the pink is 2,000, which means the 2,000 minus the pink is the blue. So I'm going to get 2,000 minus X for the base of that blue triangle. Now, I could do something with A, I could do something with B, but since I don't know anything here and I have two unknown variables, I'm going to set up a system of equations. So I'm going to say that, notice I have Z as the opposite side and X is the adjacent side in that pink triangle. So I'm going to say the tangent of 54 is equal to the opposite side Z divided by the adjacent side X. And I'm going to rewrite that as X times the tangent of 54 equals Z. And now I'm going to look at my blue triangle, and I'm going to do the same thing. I'm going to say the tangent of 30 equals the opposite side, Z, divided by the adjacent side, 2,000 minus X. And again, I'm going to get Z by itself, so I'm going to have in parentheses 2,000 minus X times the tangent of 30 equals Z. Well, now I have two equations that are both equal to Z, so I'm going to set them equal to each other. So now I have I have one equation now, x tan of 54 equals 2,000 minus x, parentheses, times the tangent of 30, and again that's just setting the pink and blue equations equal to each other, because they're both equal to Z. But now that I have this, I have a single equation with just one variable in it, x, and so I can figure out what x is. I am substituting to solve this system of equations. And this is by no means the only way to do it. This is just the way that made sense to me. So that's how I did it. So now what do we want to do? We want to get x by itself. So on the right side here, we need to distribute that tangent of 30 into that 2,000 minus x. And so I'll get 2,000 times the tangent of 30 minus x times the tangent of 30, and that is equal to x times the tangent of 54. So we want to combine like terms, so let's move that x tan 30 to the left side of the equation by adding it. So now I have x tan 54 plus x tan of 30 equals 2,000 times the tangent of 30. Well, notice on the left that x tan 54 plus x tan 30, both of those terms have an x in common, and so I can factor that x out to be left behind with tangent of 54 plus the tangent of 30. And I'm still equaling to 2,000 times the tangent of 30. Well, I have x times that whole mess right there, so to get rid of that whole mess, I'm going to divide by it. So I find that x equals 2,000 tangent of 30 divided by, in parentheses, tangent of 54 plus tangent of 30. And now that is an expression I can type into my calculator and figure out what x is. So when you plug that in, you should find that x equals 591.023 meters. But is that our answer? No. X is standing for the length of the base of that pink triangle, and we want z, which is the opposite side of that pink triangle. And think about where we started. We started with this equation right here. X times the tangent of 54 equals z. So if I want z, all I need to do is take that number I found, 591.023, and multiply it by the tangent of 54. So do that. So we get 13.473 meters as the value of z right there. And I think that's pretty cool that we were able to figure out how far away that fire was just by knowing the distance between the two towers and each of the angles to the fire. But it took a little bit of work, right? It took a messy little system of equations that we had to solve to find it. And so it would be lovely if we had a better way to approach these problems. Well, guess what? We do. That is where the law of sines comes in. So I'm going to show you real quickly where the law of sines comes from. So let's do a similar thing here. Let's look at this triangle. Wow, that was a bad line, but we can go with it. Let's look at that triangle there. Same idea. We have an oblique triangle, meaning no right angles in it. That dashed line going down with the right angle, that is just an altitude we dropped to help us come up with this formula. So let's look at angle A. And let's say that the sine of angle A equals the opposite side h divided by the hypotenuse of that right triangle, which is b. And so I'm going to do the same thing I did in that warm-up problem. I'm going to multiply by b on both sides to get b times the sine of A equals h. And now I'm going to look at this triangle over here. And I'm going to look at angle B. And I'm going to say that the sine of angle B equals the opposite side, which is h, divided by its hypotenuse, which is A. And I'm going to multiply by A on both sides to get A times the sine of B also equals h. And so I have these two equations equal to each other. B sine of A equals A sine of B. And again, notice lowercase b is the side opposite of capital angle B, and lowercase a is the side opposite of capital A angle A. And so, from this equation, I can do two different things. I could divide by b on both sides and divide by a on both sides to get the equation sine of A divided by side A equals the sine of B divided by side B. And that is one form of the law of sines that you will see. And also this is absolutely true for the sine of C, angle C divided by side C. We only showed it for two, but you could do the same exact thing with the third one there. Now, imagine if up in that previous step, instead of dividing by the sides, we divided by the sine of the angles. Well, then I would get the equation A, side A, divided by the sine of angle A equals side B divided by the sine of angle B. And again, that's also going to be true for the third angle as well, side C divided by the sine of angle C. And so these are the two different ways you will see the law of sines used. They are 100% equivalent. It depends on the context of the problem which form you should use. But what I always say is, whatever variable you're trying to find, that is what you should set up in the numerator of the fraction. So if you're trying to find a side, then you should use that formula right there and put the unknown side in the numerator divided by the sine of the opposite angle. And if you're trying to find an angle first, you should use that one right there, because again, it's just less work to get the unknown piece by itself, and that's our goal. So let's look at a quick example of how to use this. Here we have a triangle, we know an angle, we know another angle, and then we know a side adjacent to that. Now, this is the key for knowing when to use the law of sines. If you look at the way this proportion is set up, in order for it to work, we can only not know one piece of information. So say we don't know that one right there, then we have to know side A, and angle B. But the key is you have to look for opposites. So here's an opposite, 28.7 degrees is opposite of that side B right there. So that's a full ratio that we know. We need at least one of those. And then we have one other piece of information, angle C, 102.3 degrees, which will help us find side C, directly opposite of it. You're always looking for opposites. So since we're trying to find side C, I'm going to put my unknown value C in the numerator. And I have to divide it by its opposite piece of information, which is the sine of the 102.3 degree angle. That will be equal to, notice since I put the side in the numerator on that ratio, the right side of my equal sign also has to have the side in the numerator, and the side I know is 27.4 divided by the sine of the angle I know, sine of 28.7. Because now all I have to do to get C by itself is multiply up by the sine of 102.3 on both sides. And so I get C equals 27.4 times the sine of 102.3, all divided by the sine of 28.7. Plug that into your calculator, make sure you are in degree mode, and you will have your answer. Entering those numbers in correctly, you should get C equals 55.747 feet. Let's do a couple more. We have a pole tilting toward the sun at an 8-degree angle, so the sun is over here, shining down, looking happy. There's supposed to be a face there, you can't see it. But what do we know? Cast a 22-foot shadow, and we know the angle of elevation from the tip of the shadow to the top of the pole, and we want to use that to find the height of the pole. So think about this whole angle right there. What is that? Well, that's 90 plus 8 is 98 degrees. Then we have our 43-degree angle, and we have the 22-foot side there. So let's think about what proportion we could set up. Well, remember what we're doing. We're looking for opposites. So do we know the side opposite of B? No, we don't. Do we know the angle opposite of that 43-degree angle? I'm sorry, do you know the side opposite of that? No, we don't. Do we know the angle opposite of that 22-foot? No, we don't, but we could find it. So think about this super messy now triangle that we have. We have this situation going on. We know that's 98, we know that's 43, we know that's 22, and we want A. So in order to be able to find A, we need to know another piece of information, but we don't know any other sides, so we have to figure out what that angle right there is. But that's just a matter of taking 180, subtracting 98, subtracting 43, and getting 39. And so now I do have enough information to use the law of sides, because I now have a complete ratio of opposites. So let's see what I do. I'm wanting to find side A, so I'm going to divide it by the sine of its opposite angle, 43, and that will equal the side 22 divided by the sine of its opposite angle, which is 39 degrees. So rewrite that as A equals 22 times the sine of 43 divided by the sine of 39, and now it's just a matter of plugging it into your calculator. And you should get 19.88 feet as the height of that pole. Law of sines, pretty useful. Let's do one last one here. The course for a boat race starts at point A and proceeds in the direction south 52 west. Notice that bearing there, we're drawing the south line, and then opening that angle up 52 degrees in the west direction. So that's how they're getting that. Remember how bearings work. And we know that it's going in that direction until it hits point B. We don't know how long that takes. But at that point, we're going south 40 east. So again, they're giving us that south line and then opening it up 40 east to give us that angle right there. And that's going to take us to point C. And from point C, you go directly north back to point A. And it is 8 kilometers. And we want to know, what is the total distance of the race course? Well, we're going to need to use the law of sines, but before we can do so, we need to figure out a couple more angles in this triangle. Well, remember your geometry. Since AC is a north-south line and BD is a north-south line, that is creating parallel lines, and BC is a transversal of those parallel lines, and so we get alternate interior angles that are congruent, which is telling me that this angle right here is 40 degrees. And now I can find the other angle there by doing 180 minus 52 minus 40 to get 88 degrees for that angle right there. Now we want to find all of the sides of this triangle. We've got 52, we've got 88, we've got 40 degrees, and we got that side length of 8. So let's set up some proportions. We're finding side lengths. Let's call this C, and we'll call this A. What do we know? We know that 8 over the sine of 88 is going to equal one of these other proportions. So let's say C over the sine of 40. So we'll get C equals sine 8 times the sine of 40 divided by the sine of 88. Plug it in to your calculator. We get 5.145, and now we need to find that side A. Imagine how this proportion would change. 8 over sine of 88 equals C over sine of 44. Well, instead of C over sine of 44, it's going to be A over the sine of that angle, which is 52. And so then, this equation is just going to be A equals 8 sine of 52 over the sine of 88. Notice the only thing that changed was, instead of doing the sine of 40, we're doing the sine of 52. That's pretty cool and pretty straightforward. So plug that one in to get 6.308. Now, are we done? No, we need to add all three of these sides up because we want the total distance of the race course. So we need to take the original side length we knew, which is 8. We need to add to that our 5.145 and add to that our 6.308 to get our total distance of 19.453. And what are our units? Our units are kilometers. And there you have it. Law of sines in action.